Hello, welcome back. Today we have 1287 element appearing more than 25% in a sorted array. So this is key. We're given an integer array sorted in non-decreasing order, and there is exactly one integer in the array that occurs more than 25%, and that's more than 25% of the time. And we are to return the integer. So it is, first of all, it is sorted. So that's key. It is sorted in non-decreasing. The direction doesn't matter. We just need to know that it is sorted. The second thing that's key is more than 25%. So at first I thought it's 25%, then I got a failed test case with this guy because it's more than 25%. And the third thing is that we are guaranteed an answer. So answer does exist. Okay, so let's start with the first guy. Of course, the brute force approach would be, or the simple intuitive approach would be to just count everything. Get the counts of every number, then that's O of n time linear time, then go through the counts again, and then return whichever one appears more than 25 times. But see, we already iterate twice, and we need O of n space to store the map of counts. But if we notice here, because it's sorted, we don't really need to track all the counts. We just need to track whatever is the current count, and whenever the current count exceeds over 25%, we can return that answer because there is exactly one answer. It's not more than one answer, we're exactly one answer. Okay, so let's do that. What we can do is, let's have a variable, let's say left, and then, actually, let's first get the 25%. So if we want to do 25% plus, all we do is take the length, divide it by 4, and add 1. And yes, this can be an odd size. So let's say there was another 3. That's okay, because 1, 2, 3, 4, 5 divided by 4 will be 1 point some number, da da da. So we just, let's do that so that we remove whatever is the dot, da da da, and then we just add the 1. Okay, so if we have size 4, we're gonna do 4 divided by 4 to exclude the remaining integers, and then we'll add 1, and that'll be 2. Now if the size was 5, that's okay. We do 5 divided by 4, excluding the remaining integers, plus 1 would still give us 2, because that's 1.25, but then this part gets removed, plus 1 equals 2. Okay, so now we have our target. We also have our starting pointer, which is left, and we can use right to iterate. While we're iterating, we check two things. First, am I, wherever I am currently, equivalent to where I'm starting from? And I am, so the next thing to check, am I equivalent? And the next thing to check is the size. Okay, or am I 25% plus? Okay, and this is for every iteration. All right, and the size we can get by doing our right index minus left index plus 1 for 0 indexing. So 0 minus 0 plus 1, that's 1. We have a size of 1, and no, this is not greater than or equal to 25%, which is 2. So we continue R. Now, we check this guy again. Am I the same as where I'm starting from? I'm not. All right, that's okay. So what we do is we reset the starting point to where we are currently to ensure that our start and end range represents the same number. Okay, and then we move on the right. Once again, we check, am I the same as where I'm starting from? I am not, so let's reset it. And let's continue our right. So now I'm right here, and we check, am I the same as where I'm starting from? I am. All right, now we check, am I more than 25%? So here it's 0, 1, 2, 3. My right index is at 3. My start is at 2. Plus 1 for 0 indexing. 3 minus 2 is 1. Plus 1 is 2. And yes, my size is 2. My size is 2. And that represents 25% plus of the entire array. Okay, so let's do one more. So I'm starting from L. I always forget. Let's also calculate 4, 5, 6, 7, 8. Okay, so the size of this is 9, and 9 divided by 4 is like 2.25, something like that. So we're gonna exclude the remaining part, so we get 2. Then add 1 to it because it's 25% plus, and that gives us 3. So 3 is our target size. Okay, let's continue. So we have our right pointer. Are we the same? We are the same, but our size is not yet sufficient. So we move the right. Are we the same? We're not. That's okay. Reset the left. And then continue. Are we the same? We are the same, but we're only 2 and we need 3. That's okay. Move the right. Are we the same? We're not the same. So let's reset our left. Move the right. Are we the same? We are the same, but we're only size 2 and we need 3. So continue the right. And at this point, are we the same? Yes. My starting point is a 6. I'm currently at a 6. Okay? So this checks out. Are we also 25% plus? Well, 5, 5, the right index minus left, plus 1 is 2 plus 1, which is 3, which is the size of us, which is 25% plus. And we can then return the 6. All right, so let's continue. So what do? We first got quarter plus, which is the length of the array divided by 4, excluding the remainder, and then plus 1. And then the other thing with it was we remember wherever we're starting from, which is 0 to start. And for r in the range of length of array, what we did was first check, am I the same? Am I the same? And only if so, then am I at least 25% plus? And so if not, if I'm not the same, I need to reset myself. So if not r of left, if the start is not equal to, actually we can do it like this. If the start is not equal to where I am currently, we just reset the start to where I am currently. Then we take the size. So if the current window size, which is r minus l plus 1, if that is greater than or equal to quarter plus, then we can return whatever number we're currently on. Otherwise, we'll continue into this loop. And it does say we have exactly one answer, but this is unnecessary. This line will never be reached, but we'll just add that. And then we can run and submit. And there you have it. This one is pretty efficient in space and memory. And this one was 1287, element appearing more than 25% in a sorted array. Thanks so much. Happy coding. See you next time.